In this video, I want to review some big topics from our experiment design unit. And I'm going to try and go through all of this pretty quickly, and I'm not going to maybe write down all of our definitions again. If you want to see those, please go back and look at old videos or reference your textbook or look them up. I just want to talk through some of these ideas. So, the big thing, what do we get from what's different between an experiment and an observational study? The big thing to remember is an experiment has a treatment. Okay, there's actually something imposed, and that's a key word here, imposed, on our subjects. One of the great examples is, why don't we really have any data on how smoking affects humans? It's because we don't impose smoking on anybody. There's never been an experiment where we force people to smoke, and that's what makes something an experiment. An observational study is simply gathering data. Who smokes? What happens? Who doesn't smoke? What happens? But an experiment, we would actually impose smoking or not smoking on individuals. And because of that, we can gain cause and effect. Okay? That's the only way we can prove cause and effect is with a well-designed experiment. An observation only shows association. That's all we can show with that. Okay? Random sampling. Now, in both of these cases of randomness that you see here, random sampling and random assignment, the how is pretty easy, especially for the AP exam. You remember they have kind of this general way where we say, well, how do we sample or how do we assign? We put everything's name on an identical piece of paper, put it in a bucket, draw the names out, and don't replace them until we have as many people in our sample as we need or until we've assigned all of our subjects. And that is kind of a catch-all. The names on identical pieces of paper in the bucket, draw them out and don't replace. Okay, that's an easy way to do it. Another way is, of course, assigning everything a number and using some kind of technology or a random digit table. But the how part of this, that's pretty easy. The why isn't that bad, but it's something you gotta know and gotta remember. Random sampling is done to generalize our results. Okay? The reason when we do like a presidential poll or an election poll, and we take a random sample of 1,000 people and ask, is because we're trying to generalize to the whole population. Okay? So we do random sampling to get good data so we can generalize. While random assignment is more for experiments and again trying to prove cause and effect. And it's basically, if we randomly assign, we hope that any of those kind of lurking, confounding, underlying variables get evenly split up into our two groups, our control and our treatment group, and that way we can prove that the treatment was the cause of any differences we may see. Okay? So again, know why we do those two things and how. Statistical significance. Now, this term has kind of grown since we last talked about it because when we talked about it in experiment design, it really came down to the fact that the observed effects that we see can't just be due to chance. We see a difference between the group that got the drug and the group that got the placebo, and that difference is enough that we say the real drug must have caused that difference. That's statistically significant. Now, of course, we've added to that. We've put in levels, 0.05, 0.01. We've added the idea of a p-value and rejecting and failing to reject and what that means. But in terms of just experiment design, what it means to be statistically significant was what we saw, this effect that the treatment caused, was it large enough that we think, the treatment actually did cause it? A matched pair design we've talked about pretty recently. And I'm just going to write down, a couple of kind of ideas here. Of course, very common is person to themselves, kind of a before and after. There was an AP problem once about a group of women, and they were instructed to send a text while sitting and then send the same text while walking. and the time was noted. Well, and of course, in something like a matched pair, you use randomness to decide which thing is first. Do they send it sitting or send it walking first? So you can still involve randomization in a matched pair, but that's a really common matched pair design. Another thing, I always have this example of the plots of land. And imagine that like you're in your yard and you rope off a plot of land and you say, well, I'm going to use fertilizer A in this plot and fertilizer B in this plot. And then I go over to my neighbor's yard and I do the same thing, A and B. And then I go to my other neighbor's yard and I do the same thing. Well, this is a matched pair, right? Because you want to compare A to B in your yard, your neighbor's yard, and your neighbor's yard. You don't want to compare A to B here and B to A there. So this is another way to do a matched pair. All right, blocking. Blocking is another experiment design idea where we use some categorical variable to divide subjects before we experiment. You block by, I'm going to write it down. You can block by like gender. This is a common one. Gender. Or age. Or weight. Or height. Or something. You say, well, I think that this new blood pressure medication, it might affect men and women differently. So I'm going to block by gender. I'm going to put the men in one room, the women in the other, and then I'll use random assignment to get my treatment and control groups in each gender. Okay, that's blocking. That's very similar to a stratified random sample, or it feels similar, I should say. I want to explain the difference in just a minute. A bias. Of course, there are many types of bias. Response bias, which means anything where it would cause the respondent not to give their true opinion. The wording of a question, if certain groups are being favored. What bias means is that outcomes, for whatever reason, are favored over others. Okay? And really, what it leads to are samples that are not indicative of the population. We get a result that it does not match the feelings, and we can't generalize because of it. It's a biased sample. All right, let's talk about some sampling methods. A cluster sample. A cluster sample is one where you use randomness to pick an entire group. For example, I put every teacher at the school's name in a hat. I pick one teacher's name out and I go to that classroom and ask that class of students what their opinion on something is. So I use randomness, but I just picked one name out and then that whole group got picked. So think about like you picked a cluster. Okay? Voluntary response. Remember, you choose yourself to be part of the survey. You go online and fill something out. You mail a card in. That's voluntary response. A systematic sample. This is one where you create some kind of system in your head. You say, well, I'm going to stand outside. I'm going to ask the fifth person, every fifth person that walks by me. You have a system, and you're not asking everybody. You're not being biased. You have a system. A stratified random sample is where you say, I'm going to ask 100 high schoolers. And you think, well, there's always that chance through randomness, it's a slight but possible outcome that I get all seniors, that I ask 100 seniors. So you decide, I'm going to break my master list of students into grades, and I'm going to pick 25 from each grade. That's a stratified random sample. Okay? You ensure that each category is represented. It doesn't have to be equal. It could be proportional to the number of students or something, but you make sure that every group can be picked. That is a sampling method. This is how you gather your data. Blocking is an experiment design. Okay, that's the difference between the two. Blocking has to do with experiments and breaking them into groups to impose a treatment, where observational studies That really lines up with more a stratified random sample. Okay, so one is an experiment technique, and the other is a way to pick a sample. A simple random sample. Every person, every group has a chance to be picked. This is the most common. This goes back to, we put everyone's name in a hat and draw them out. That's a simple random sample. And finally, convenience sampling. This is just asking the people that are easiest. You go down to lunch, you ask your lunch table. The one other thing I didn't put here that I might just add is the census. And of course, that is where you ask everybody. So this was some big ideas, very quick, about experiment design.